This section is on how a compact disc works. This topic often comes up in question on paper 1 and also paper 2. Now, a CD or DVD is basically a piece of plastic with some aluminium, acrylic, and then you have the label on top. If you notice, on the aluminium there are these bumps, and this is where the information is stored. We have these tracks. This track is basically a combination of lands or bumps and pits, as they're known. The width is 0.5 micrometers and there's 1.6 micrometers between them. The laser reads the differences between the lands and the pits. We have a difference between CD and DVD. In a DVD, the distance between the tracks is 740 nanometers. In a CD, it's 1.6 micrometers. In other words, 1600 nanometers. In other words, it's twice as big. So the information you can get on a DVD is considerably more than that on a CD, which means that you can have a greater density of information on a DVD. You can pack more information on a DVD than you can on a CD. So basically what we have, it's stored digitally as a series of zeros and ones. These pits and these lands or bumps are etched onto the CD. The edge of a pit is considered a 1. The middle of a pit or the middle of a land is considered 0, and we'll show how that works soon. Here we have the widths. The lengths of the lands can vary depending on how many zeros you have. The depth is important. This is 125 nanometers. The disc is read from the inside and then moves outwards. And it's pretty much the same for the DVD, but you can get much more information on. And it's not 125 nanometers. It's less for a DVD. Now this is the important thing. When the laser reads the middle of the land, it understands that to be 0. When the laser goes from a land to a pit, that change is read as a 1. When you're in the middle of a pit, that's read as 0. When it changes from a pit to a land again, that's registered as 1. This is the important thing. When there's a change, there is a signal of 1. When there's no change, it's 0. And we're going to look at why that is. If we have a light of wavelength 500 nanometers, which is instant on here, this beam of light and this beam of light, they interfere constructively when they're picked up by the laser reader. However, when it goes between a bump and a pit, some of the signal has to go further. This further path that's taken will give a path difference, and if this path difference is half a wavelength, then we will get destructive interference. So the path difference is half a wavelength, which means the height of this is going to be 1/4 of a wavelength. So the bump height is basically 1/4 of the wavelength of the light that is used from the laser. So this is the radiation. It comes down and reflects. This goes this way, and then this radiation goes further. The depth of the pit is a 1/4 of a wavelength, basically because you need a path difference of 1/2 wavelength, which is the difference twice, because it goes down and up. An example would be if you use light of 500 nanometers, you divide by 4, so the bump height will be, or the pit depth will be 125 nanometers. To explain how interference of light is used to recover information stored on a CD, so you need to discuss that 4 points. Students must know that destructive interference occurs when light is reflected from the edge of a pit, and calculate the wavelength of laser that must be used for a bump height of 125 nanometers, and to be 4 times as much. The reproducibility, the retrieval speed, and the portability. This is digital. The quality can be excellent depending on the sampling rate. The quality of the analog signal can also be excellent, but is prone to corruption and is prone to noise. How reproducible is it? Well, if it's digital, it can be reproduced almost identically. With an analog, every time you reproduce it, there's going to be some depreciation in the quality of the sound. It's easy to retrieve information digitally. You can have random access, but with a videotape, for example, you have to fast forward until you actually find the part on the tape. Portability, it is very compact, it's usually small, whereas for analog, normally you have a large volume for the same data. Implications for society. You need to discuss the moral, ethical, social, and economic and environmental implications, the cost, the privacy, ownership of data, and accessibility. So you need to do your own research on this and find out about this. Basically, the complexity of the code. Digital is very complex, analog is very simple. The quality, it's high quality. Analog is also high, but it can be corrupted. How reproducible is it? Well, it's can be made to be identical, and every time you reproduce analog, it affects the quality. The retrieval speed can be very quick, and analog, it can be quite slow. Portability, that's very portable and not so portable. Manipulation of the data, that's easily manipulated. Moral and ethical, rights of ownership. There are social issues about sharing information, the digital age. Economic decisions can be made based on information. You can have cheap storage. Environmental, there's some saving, but there's also some waste.